So student, today I would like to do revision on KSSM Mathematics SPM exam on mathematical reasoning. So as you know, mathematical reasoning is very important because it's part of the high order thinking question. So we have three types. One is we call as converse, and we have inverse, right? We have inverse. We also have one more is contrapositive. So what is converse? What is inverse? What is contrapositive? Let's revision for these three important terms. Converse. So when we talk about converse, meaning that let's say we have the statement if P then Q. We start with the if P then Q beginning. If P then Q, then Q. The P and Q here are statement, okay? So the statement can be something like 12 is a multiple of 3, something like that. 12 is a multiple of 6, 12 is a multiple of 3, 12 multiple of 6 are the statement. So if P then Q is the original statement. So if we want to do converse, we have to swap the position of the P, go behind, Q, take over the P's place. So we say if Q then P, right? So it becomes if Q then P. That is called converse. Alright? If P then Q, if Q then P, that is called converse. Okay. So now let's see this example. If 12 is a multiple of 3, this is a statement P, then 12 is a multiple of 6. Okay, so now if we want to do converse for this one, the above statement, so this is P, this is Q. So if we want to do converse, that means we have to write the Q first, which is 12 is a multiple of 6. This is Q. And then, sure, you have to use a if and then. And then we will use a P. 12 is a multiple of 3. If Q then P. This is so-called converse. Alright, so make sure the keywords if, then is there. Alright, that is converse. If P then Q, if Q then P. Now let's proceed to what is inverse then. Inverse, can you see the line here? This is called till. When we read is till. Till means not. Till, if till P, then till Q. The till here means negate, not P, not Q. So if let's say we refer to just now the statement, the original statement is this one. We want to do inverse. Okay, let's say we want to do inverse, we are going to do inverse. So what we need to do is we must make sure we negate the statement. So if 12 is a multiple of 3, we have to add the word not. If 12 is not a multiple of 3, then 12 is not a multiple of 6. Right? This is called inverse. Okay. So we will negate the P, will negate the Q, but we don't change the position for inverse. For contrapositive is something to do with the converse. Alright. There is a connection with the converse. That means we will change a position first and then we will negate. Right. For contrapositive, we will change a position. That means a Q comes first and then P, and then we negate till Q, then till P, not Q, then not P. So for example, like just now the example, so we will write if 12 is not multiple of 6, then 12 is not multiple of 3. In fact, we are referring to this one. We are referring to this one, we just negate. Alright, we just add a not. We just add a not there. A not here. See a not? is not a multiple of 6. So we add a not here to negate. And here is 12 is not a multiple of 3. So we negate the converse. So this is called contrapositive. Alright, so I have highlight to you. We have 3 types. One is so-called converse, one is contrapositive. So make sure you are aware that you understand and memorize the concept of the contrapositive, right? Okay, contrapositive is something to do with the negation of the converse. That's all my revision on contrapositive, converse, and also inverse. So then for the next one, let's have a look at arguments. In mathematics, we have inductive arguments, strong and quotient. Okay, we have inductive argument, strong and quotient. Okay, we also, for arguments, we have 2 types. One is so-called inductive argument, strong quotient. The other one is called deductive. Alright, deductive argument. For deductive, we will use the terms, we always use the term valid sound. Okay, so let's have a look for inductive argument. So for inductive argument, we will use the term strong quotient. Make general conclusion based on specific premises. For example, we have premise 1 like this, premise 2 like this, premise 3 like this. Then we will study the pattern. The 2 is there, so we copy. That's conclusion. How we make the conclusion? Bracket, every term also got bracket, so we will write 2. First we write 2, then every term also got bracket, we write bracket. And the one keep on changing, 1, 2, 3. This one 1, 2, 3, right? 1, 2, 3 we don't do first. We will just follow to identify the pattern which is not changed. 1, 1, 1, right there. And then what is changed, we will replace with n. So 2n minus 1. So that is how you write the conclusion. Just like that, there's no equal sign. Please don't write like this. This is wrong. Alright? Or make sure you don't write like this. This is totally unacceptable. It's a statement. Just a statement like this. Alright? Then you have to state the n follow here. 1, 2, 3. The n must be written down. Okay, the n 1, 2, 3. So n equal to 1, 2, 3 and 3 dot. Is always the norm, 3 dot. Alright, 1, 2, 3. Follow the premise given. So this is called making conclusion by inductive argument. So we call it as inductive argument because we have many specific example and then we induce to one general statement. This is called general statement. 2n minus 1. So that is how we make a general conclusion based on specific premises. So specific premises, number 1, number 2, number 3. We have 3 specific premises. Alright, so for deductive argument, we always say valid sound. So make the specific conclusion based on general premise. General premise. From one general premise, we will make the conclusion. Example, we always start with the or. Okay, we have 3. We have to study the pattern first. Or A is B. Okay, or A is B. C is A. Or A is B, C is A. Notice that we will cancel out the or. We will cancel out the A, which are similar. And then the balance is we always start from the premise 2 and we will connect to B. C is B. That's how you do connection from premise 2 to premise 1. C is B. Okay, so we always use a highlighter, highlight the similar one, and then we cancel out. That's how you write the conclusion for the type 1. We have 3 types in fact. This is first type. Second type we have if then. Okay, you have to memorize the type. Okay, so let's see this one, premise 1. If P then Q, right? If P then Q, so I'm going to highlight the if P then Q. Premise 2, P is true, and followed by Q is true. This is a conclusion. Okay, this is type 2. You have to follow exactly the pattern of the 3 types of deductive argument. Then for this one, for the third type, we are going to see the pattern is almost the same like second, if P then Q, but here not Q is true. Not Q is true. It's the Q, not Q. There's a not, there's a Q is true. Just now was P is true. Now not Q is true. So if not Q is true, then not must be there. Not P, here not Q, then not P is true. Right? So this is a pattern that we need to follow. 3 pattern for making specific conclusion based on the general premise for deductive. Okay, please memorize the three format. Okay, again I would like to highlight to you the 3 format is like this. Okay, the first one is all A is B, C is A. Then how you do? All cancel, the similar one cancel A, then connection from premise 2 to premise 1, C is B. For the second type, if and then must be there, and then P is true, Q is true. For the third type, still if P then Q, not Q is true, not Q is true, right? Q, then not P is true, right? There are 3 patterns. Please memorize it before we can solve all the questions involving mathematical reasoning.